And everybody has a good graph here, and I think everybody's got some estimates. So put a number in for G here. Let's say it's nice round number 20. Let's say D is 10. Fair enough. And first of all, where's the vertex? Well, here's the vertex. Coordinates of the vertex appear to me, well, to do the coordinates of the vertex, you want to draw a couple of projections. Here's the x coordinate of the vertex, here's the y coordinate of the vertex. It looks like this is a little less than halfway G. The halfway point looks to be about right here. So I'm going to say that this is actually with 8. And this looks like a little more than halfway to 10, but I'm going to say, yeah, we'll say this is 6. So the vertex is approximately 6. You're only doing pretty well with this, okay? And again, please stick that. Okay, D is 10. And this coordinate, more than I'm going to say this is 5. Somewhere between 4 and 5. Okay, and D is 10. So this point is nearly 5. Okay. Now, on your homework, you saw graphs. So, what's a formula for this function? Okay. So one way to do it is if you have a parabola, it's pretty easy to identify H and K. Okay, because the vertex of your basic squaring function is what's the x coordinate of the vertex of your basic squaring function? Show me with it. Right. What's the y coordinate of the vertex? 0. It's 0, 0, right? So the vertex is 0, 0. Now, if I want to take that graph, let's say the basic squaring function has a graph that looks like this. And that's hard to read, but just says basic squaring function. Okay. Now, to make this graph look like this graph, I've got to do a vertical stretch. And actually, it's going to be a vertical compression because the graph's going to have to flatten out. So this graph is sharper than this one. And actually, if I drew it to scale, it would be much sharper. Still, we're not going to put them both in, just to give you the perspective, okay? So the fatness of the graph has to increase. You got to vertically compress it. So you're going to have to multiply by some number A that's less than 1. Because that's your vertical stretch. And also it's A times x minus h squared plus k. So this is your basic squaring function shifted h units in the x direction and k units in the y direction, right? Well, how far do you have to shift this graph match this one? Well, you're going to shift the vertex. You're going to have to shift it 8 units right, 6 units up, right? The vertex is the easiest point to identify. So you just go by the vertex and you see immediately what h and k have to be. Okay, does that make sense? So vertex of your basic squaring function shifts from 0, 0 to HK. HK equals H6. The equation is y equals a times x minus h squared plus k equals a times x minus 8 squared plus 6. So you've got that much of your equation as soon as you estimate where the vertex goes. Okay, now I saw, and I haven't been over everybody's paper, I was able to give people, especially people who email me a copy of their work, which is optional. But if you email me a copy of your work, I'm going to make every effort to go through your work and see how it matches up with what you've written, so that if you make a mistake and you have good documentation, I can say something about what your mistake was. Okay. But I saw a lot of places where people had the H and the K right, but didn't get the A. So people were pretty good, a lot of people were pretty good at estimating H and K. So I went through and gave half credit for that. And I'll try to do the same thing. And if you've got H and K right in the graph, and I haven't given you partial credit on it, go ahead and email me. Yeah, number 7, I think I got H and K right. Take a look. Okay. Okay, well, anyhow, there it is. Now, what about this A? Well, there are only 3 variables, or 3 parameters, whatever you want to call them, left here, y, a, and x, right? And when you estimated this, you said that when x is 5 and 10, y is 5. So you can plug 10 and 5 in for x and y and solve for a. Okay. So take your coordinates of this point, write your, for your information, if this equation, plug in 2 values of x and y and solve for a. It's very straightforward once you see what's going on. And it's a kind of a big deal to be able to do this, to be able to think through this. If you're able to do that, you're doing real well at this point, at least with transformations. Okay, so our estimate was that the point 510, the point I asked you to estimate here was on the graph. Y equals 10 when x equals 5. Thus, put 10 in here and 5 in here. Get this. Very straightforward. X is 5, Y is 10. And now the only thing we don't know is A, and we just do the arithmetic. N equals 9A plus 6. And I'm not going to A is 4/9. Subtract 6 from both sides, you get 4 divided by 9. I'm not going to go through the details of that equation. You can so our equation is number right, what's the number? Okay. Now, another thing we can do with this, kind of make yourself a note. I'm going to do it kind of quickly. You should do it on your own, but I'm not going to give you time to do it. I think we do some other stuff. There's another point you could have estimated. For Y value D, that would be like over here. So let's see. This is 8, that's 20. And halfway would be 14. So that's about 12. Another estimate for Y equals 10 might be X equals 12. It could have been 13, but my honest estimate here came out 12. Okay. If it was 13, everything would be perfect. I'll tell you why in a minute. Okay. According to our equation, if X is 10, or 12, we get this, right? That equals 4/9 of 16 plus 6, which is 64/9 plus 6, which comes out 13 1/9, not 10. Okay. But 13 1/9 isn't all that far from 10. If I drew my parabola completely symmetric about the line where and you can understand that since your basic parabola is symmetric around the y-axis, this parabola is going to have to be symmetric around y equals 8, x equals 8, okay? And this point will be as far on the right of the axis as this is to the left. Okay. So this is 5 units. If this is 3 units to the left, this should be 3 units to the right. And 11, if I'd have plugged in 11, I would have gotten the same thing. Okay. What I did was when I plugged in 12, it's kind of a measure of how unsymmetric my actual picture is. Picture isn't completely symmetric. So we got an estimate of 13 1/9. That's not 10, but it's close. So I don't have a totally accurate equation for this parabola, but based on estimates and hand sketches, it's a pretty good estimate. Now, in the homework, if it was a parabola, you could see where the vertex was, right? So you know what H and K are. Okay. And then you just estimate one more point on the graph and solve for A. So that's a good way to do it. Okay, sometimes you can see it in other ways as well. But if you can do that, then I think that's good. Now, the other thing is, what do you do if you looks like I've got a critical board shortage here. Got a nice big rough board over there. So I can be totally out of business. Now I got the back here this board. So if the graphs look like this, What point on this graph corresponds to x equals 0? On a basic function. What basic function does that look like?
I was just-
You could have said, turn on the camera, bonehead. Okay, that's perfectly all right. That was actually my nickname in high school. That was one of the nicer nicknames. Okay, we insulted each other a lot, best athlete in high school was my close buddy, Pat Boyd. He threw football almost 80 yards. I mean, it was on lots, 40-yard lots. He'd be at the boundary one, I'd take off running. About the time I hit the next boundary, he'd throw the ball and I'd catch it just short of the boundary of the next house. And pretty amazing. I just throwing a football with him, I developed a pretty strong arm. 55 yards, not 80 yards. That's a pretty good arm for a skinny bonehead. Okay. It was just a lesson of that is if you're messing with somebody who's on a high level, it raises your level. Okay. Anyhow. So anyhow, there's both vertex. Okay, yeah. Here's a basic cubing function. Here's a graph, and we identified this as a graph that looks like the basic cubing function there. I was just waving at everybody to be sure they know what the graphs of basic functions look like and always be able to draw them in a very short time and show the arithmetic. Okay, that's non-negotiable. You got to be able to do that. So we recognize that as your cubing function. And right here is the key point. That's like the 0, 0 point. That's what we kind of call the vertex. Usually you apply the word vertex with parabola, but it's legitimate to do that without a power function. Any positive power. Okay, so we identify this as a transform y equals x cubed function with a vertex here at given our estimates. 711. Okay. There you go. 711. There's 711. Okay. So our equation is yes, for f of x equals x cubed. Okay. And make sure you understand why if you have a f of x minus h plus k and f of x is x cubed, then this becomes a times x minus h cubed plus k, because this is a form for any transform function that has a vertical stretch compression and a horizontal vertical shift, whatever the function is. And it's important to know that. Okay. Now, y equals a times the quantity x minus h squared plus k. What's h? 7. K equals 11 because your basic function is down here and this function is shifted to stretch compressed. Okay. So we estimate a point. Good point to estimate, but estimate it to be an intercept if you got one. Didn't have one with that parabola, just happened not to have an intercept with parabola, but we could estimate this point. And if that's 11, I'm going to say that's 5, 0. So y equals 0 and x equals 5. And y is 0, substituting 0 for y and 5 for x. It's the same thing we did, but with a different function, which we have to recognize. So A is going to equal eight over 11. This is -2. If you cube -2, you get -8. And I there's a function. And it goes the same for any other function. If you know what the basic function is, you want to generally just ask yourself, what happens? You know, where would the origin go to give me this function? Okay. And that even works if you don't have a point at the origin. If you've got a graph that looks like this, well, you try to see what this point is, right? So you can see that this is a shifted reciprocal function, shifted and maybe stretched. So again, you can recognize the h and the k. The h and the k is where the origin would go. Even though the graph doesn't go through the origin, you can see what the asymptotes are. So you can see where the origin would be. Then estimate a point, do the arithmetic. Because once you have the h and k, the arithmetic is really easy. You just remember to estimate a point and extend it. Okay, so what I ask you to do is do the table and graph of your basic exponential function. Okay, then I want you to reverse the columns of the table, meaning your y values become your x values and your x values become your y values, and graph what you get from that table. I won't ordinarily remind you, especially on a test, your basic exponential functions, y equals 2 to the x. You need to know what that looks like without even having to do the table. And you need to be able to do that table quickly, because you're going to have to do that on a major quiz here in a couple of weeks. And you have to show the arithmetic so that you have complete connection to that function, so you really have some insight into the way those numbers work. Then start doing the algebra. Okay, well, enough of that. We use -2, -1, 0, 1, 2. We don't use 1/2 because we would have to get a calculator and do that, and there's no calculator involved. Okay. Also, it's not exact, so our basic points are all going to be points that we calculate exactly without having to use any machine. Okay. Just reiterating that. Anyhow, I think everybody got it. Everybody got this table. And again, that's good. So I won't say anything about the fact that it took some of you a few minutes to do it, because you're being meticulous. Okay. It'll be done reasonably quick. I want to be quick on these. But again, we were pleased with what I saw there. And well, if we reverse, reverse table is going to have your 1/4, 1/2, 1, 2, 4, here, and your -2, -1, 0, 1, 2, here. Now, the graph. Okay, this is a table of what we call the inverse function. An inverse function switches x and y. It switches your independent and dependent variables. That's all there is to an inverse function, except the algebra gets a little hairy. When you try to calculate an inverse function, your algebra has to be into it. And we'll do that in a couple of minutes. Okay, so your basic exponential function, as you know, has a graph that looks like this. I've seen some pretty good looking graphs. And some people drew the graph before they did the table. So I know some of you know what the function looks like. I think most of you probably do. But if you got to use a table, for right now, that's okay. Make sure you're really conversant with this by the week after next. Okay. So I kind of missed this point, so it's not a great graph. If I plot these points, well, we need x equals 1/4, which is going to go here. This isn't physically 1, this is 2. I think everybody knows that. The standard table. So it's 1/4 -2. Well, that puts us. There's 1/2, there's 1/4. That puts us down here. And then we have 1/2 -1. Well, here's 1/2, and here's -1. And then we have 1, 0, here's 1, 0. And we have 2, 4. Sorry, 4, 2. Now, that's a little inconvenient because our graph only goes out to 2 here. So we're going to have to extend our axis out here 2 more units. So let's say 4 is out here. And now we have the point 4, 2. Well, here's y equals 2. Here's x equals 4. That gets this point out about here. We got this point, this point, this point, and also we've got 2 more. So these points line a nice smooth curve. It can be seen as kind of a reflection of this curve. There you see an open math. You get 2 as the exponential function. Open math hasn't done much with exponential functions. I think you need it from the beginning because the graph is so convenient. Like right now, this is the most convenient graph to inverse. There are complications with all the others. Okay. At least most of the others. Okay. So here's our basic exponential function y equals 2 to the x. Here's the inverse. The basic exponential function. And that is, you don't really need to know this or remember, but if you do, you'll need it later. And we'll talk about it later. But it's what we call the base 2 logarithm of x. No, we don't get to logarithms for another month or more. Okay. Any exponential function is what that comes sometime in November usually. Okay. But it's the inverse function. Okay. And you see that what we've done is we switched x and y. Like we have the point 2, 4 here. Go down here, we have the point 4, 2. Okay. We have the point 1, 2, and here we have the point 2, 1. We're just flipping X and Y. Now to do that in a piece of paper, you kind of have to reverse the graph, turn it over, and rotate. Okay, or at least turn it over and rotate. That's kind of interesting the way that works, but there are all the connections you want. Okay, so an inverse function look at X and Y. That's the first intuitive basic concept you want to have for an inverse function. It gets a little complicated in some cases. Like if you do the inverse function of a squaring function, well, that flips it over on its side. Do like this, okay? That's no longer even a function because it no longer passes the vertical line test, right? And that's because the function itself isn't one-to-one. Okay, it's not one-to-one. For any y value, you have two x values on that parabola. And we did that, the parabola that we started class with when we were trying to find equations of functions, okay? Estimated y equals d, there are actually two possible estimates, and that's the case for any y in the range of the function. In that case, we have to say, you know, I'm going to just chop that thing in half, hit the y-axis and throw away the left half. Now I can do an inverse function because now I've got a branch of the squaring function that's one-to-one. As soon as I throw away the negative part, you get a nice one-to-one function. And you invert that graph, you know what you get? You get the square root function. So if you do that and sketch it out, and you see that with open math, do that and sketch it out, you should recognize that as your square root function. That's not one of the five most basic functions. It's an inverse of one of the five most basic functions. So it's also basic, it's also a toolkit function. The logarithm function is a toolkit function. Okay. We're not using the logarithm right now, but we have used square roots. So you need to both remember what the graph of the square root function looks like, be able to construct it, but also be able to construct it as the inverse of a branch of the squaring function. Well, it's not too hard to understand. I think open math will make that real clear for you. And if not, we'll talk about it next time because I'm kind of questioning it. But incidentally, let me pause for a second. That's what the inverse function does. So let's apply this. Now, if the function is f of x, then I write f with a -1. It looks like an exponent, but it isn't. Because you can't do an exponent on f. F is just the name of a function. Okay. So if I do a -1 on the name of the function, we're not going to do the reciprocal, the name of the function anymore than we're going to square an aardvark. Okay. So f inverse of x if f of x equals 3x minus 5. Okay. So you could do a table, y versus x, but first of all, you let y be f, y equal f of x, right? And then you can write y equals 3x minus 5. You write y equals 3x minus 5. to get F inverse of X, you're going to switch X and Y. You're going to switch X and Y, then solve for Y. Okay. So do that. And just, don't bother writing down all my words. Just write, Y equals 3X minus 5. Switch X and Y and solve for Y. Okay, y'all did real well with that. Not everybody had time to finish it by the time it came around, but most did by the time I got to them. So you switch X and Y. And you get X equals 3Y minus 5. Solve for Y. Well, okay, you got X equals 3Y minus 5. X plus 5 equals 3Y minus 5 plus 5. X plus 5 equals 3Y. X plus 5 over 3 equals 3Y over 3. So that Y equals X plus 5 over 3. No big deal. And for a linear function, it's always easy. For a rational function, it can get a little bit tricky. Boy, I'm running out of board space. I'm going to do stuff like this. Okay. So we got this now. So F inverse of X then is X plus 5 over 3. One can show that F of F inverse of X equals X. Now to do the composite of F with F inverse of X. You should end up with X. And of course, we kind of anticipated this last time because we did an example. I asked you to show that F inverse of X was X. And also F inverse of was an F and a G. But F of G of X equals X and G of F of X equals X. So we did that last time and everybody, I think, was pretty good with it. So I think it'd be pretty good here. So I'll have to write it here. I'm going to write out F of X equals 3X minus 5. F inverse of X equals X plus 5 over 3. So F of F inverse of X equals 3 times F inverse of X plus 5 because I've replaced X by F inverse of X. So I'm going to replace this X by F inverse of X. That equals 3 times X plus 5 over 3 minus 5, not plus 5. That equals X plus 5 minus 5, and that equals X. Okay. And if you did F inverse of F of X, it would also equal X. So there we have it. So you should be in good shape on most of that assignment.